Hi everyone and welcome to Asami Rat Care. Right, so today's video is going to be an extension on the genetics video I did probably about just over a week ago, and it's going to be looking specifically at Punnet squares. So Punnet squares are a tool that we use in breeding to predict the outcome of a litter. And I'll be honest, with Punnet squares, I don't really use them anymore, and actually a lot of breeders don't. But that doesn't mean there's anything wrong with them. What it is once you've kind of bred rats for a little while, there's certain kind of patterns that you kind of just automatically now think of. So when I'm thinking about, let's say, a rat that carries dumbo with a rat that actually is a dumbo, then I know it's going to be 50-50, and it's in my head now. If I have two carriers, I know there's going to be 25% dumbo, 75% not dumbo, and just things like that that just soon become kind of almost second nature. But Punnet squares are really, really useful for you to start learning those patterns, and actually for you to reassure yourself that you're kind of getting it right. All they are is a very simple little grid. So we have the whiteboard out again so I can demonstrate you. And let's start with that example. Let's start with dumbo. And the reason I use that is dumbo is a very simple recessive gene. So as I was talking about last time, we have dominant genes, recessive genes, etc. And with dumbo, all it is a rat that carries dumbo. You can't tell, it isn't half dumbo. I've seen that thrown around a few times. It's either dumbo or it's not, but it can carry dumbo. So for instance, who have we got around here? Fu here is very much definitely a top here. However, she carries dumbo, and the reason we know she carries dumbo is somewhere running around on the floor, who's just darted off doing something naughty, is her daughter, and her daughter is dumbo. So we know Fu must carry it because it's a kind of recessive gene. It basically means that she has to carry it because she has to have passed it on. If you think about the kind of ball exercise we were doing before, in order to pass that kind of the two copies that need to show dumbo, then we must have something with dumbo. So let's look at dumbo. Now dumbo, I'm going to use, one thing I should mention, right, every gene that we're talking about will have a particular symbol. I may have covered it last time, but it's been a while and I've forgotten whether I did or didn't. And you typically have kind of a big letter, it's called dumbo, and a little letter for the kind of recessives. And I'm just trying to see, I think that's not very clear because of the light. You know, you get a lovely new light and it's great and everything, but then it doesn't quite work. Let's put it in the middle here. So DU and DU. I should say the actual symbol for dumbo has not yet been kind of like confirmed, so people use different things. This is the one I use just because it's easy. This can also be mistaken for down under. Some people use it for down under. In reality, it kind of doesn't matter unless you're communicating with other breeders for the purposes of just working out your own kind of maths effectively, though this is really simple maths. You don't have to use any particular, you could use D for kind of the purposes of your own maths. D is actually normally used for blue, not Russian blue, but British blue or American blue, depending what country you're in. But yes, so there's different kind of letters that we traditionally use, and the most commonly used is agouti, which is big A, little a. But let's use dumbo just because it's the one I've started off with. So we're going to use a big DU versus a little DU. So big DU, because this is a recessive gene, big DU just basically means let's not do anything, let's stick with what we've got, which is top here. Little DU means there I'm either carrying or expressing the dumbo gene. So we have a few different options of rats, you see, we can have with this. You can have the not dumbo carrier, which is this DU to DU. We can have the not dumbo that isn't a carrier, which would be DU, DU. Again, we're using this, always has two. All genes come in pairs, which makes things simpler. That's one of the few rules you have in life. And then you have dumbo, which is DU, DU. So that rat's expressing dumbo. I have a perfect example of a rat expressing dumbo here. Yes, for those that don't know, dumbo is when you effectively the rat version of lop-eared. So they have the ears on the side of the head, versus Snufkin here, who is very definitely a top ear and not dumbo, or whatever you want to call it. standard ear, some people call it as well. It doesn't really matter, again, it's all about means of expressing yourself, though you get some people that get very upset over that kind of stuff. Right, so don't fall off. Right, so that's what we're kind of looking at. So we've got these few different options. So where does Punnet squares come into it? So Punnet squares are basically a case for us to think about what we might get from a particular pairing. So let's say I'm going to take a not dumbo carrier and I'm going to breed it with a dumbo. So how do we know what we're going to get from this? So what we do is create a little grid. And this is kind of quite a simple thing. And along the top, we have mum or dad. It kind of really doesn't matter which one you put at the top. Again, in fact, let's make it a bit easier. Some people will have a particular kind of method that they always follow. They will believe that that is the way to kind of like demonstrate it. All we're learning to do with this is to predict an outcome. This doesn't have to be published in a scientific paper. So basically do which works for you best. I'm pretty intermittent, I will say. I sometimes do mum on top, I sometimes do dad on top. To be fair, I mostly don't do them. I only do them when I'm trying to teach people a bit of genetics. So we've got mum on top and then dad. Let's make this a little bit higher up just so I can fit some stuff. Right, so the first thing we need to know is what genetic kind of code they have. And I will say for this, you only want to look at one thing at once. So you can't do the world's biggest, most mammoth Punnet square. Well, you probably could, but it would give you a headache and blow your brain. For every single different of these kind of locuses that we were talking about before, you want to do one per locus, and that's the most straightforward way of doing things. If you do, and then you can look at what the outcome of those locuses afterwards and then work it from there. But for this, we're just looking at the dumbo locus. The rat might be agouti, it might be black, it might be cinnamon, it might be topaz, it could be anything. We're just looking at that one locus. So dumbo versus not dumbo. So let's say mum is dumbo. So we're going to do du, and then dad is a dumbo. No, sorry, not a dumbo. Dad is a top ear, a standard rat, but he carries dumbo. So we're going to say du and then du. So dad has one of each gene, mum has two of the dumbo gene. So then all we have to do with a Punnet square, and this just looks at kind of probabilities. And if I didn't mention it last time, I'll definitely mention it now. Probabilities are not hugely reliable. Probabilities are exactly that, probability, and there's a probability of each rat being that. And overall, if you breed hundreds and hundreds of rats, you're going to get roughly about those probabilities. However, life likes to kind of like be a bit of an asshole at times, and you don't always get those probabilities. Usually you don't get the probability you want to happen, or you get a full litter of them. It really kind of depends on kind of fate's mood. Right, so what you do as a matter of course is you will always start with the dominant. The reason you do that is obviously because the dominant's going to overpower that like recessive. It's just a good habit to get into. But again, if you're not going to do that, it doesn't hugely matter as long as you can read and understand the results. So, oops, I've got the rats out, so if I'm distracted as usual, it's their fault. Right, so from dad we've got a copy of the du, and from mum, if I go there, we've got a copy of the little du, and I'm going to get absolutely awful at kind of saying these words and expecting you to be able to understand inflections from my tone about whether I'm capitalising or not capitalising, but bear with me really. So that's one possible option. Next possible option is exactly the same, because we've got another capital du from dad here and then a little du from mum here, so exactly the same there. Right, next we go into the next one. So we've got a little du from dad and a little du from mum, and exactly the same here. So effectively with what we've got there, if we look at this code chart at the top, here we've got dumbo carriers, and here we've got dumbo, kind of just dumbos. So it's 50-50, and if you mentioned before, that's a pattern that I just recognise now, because it's one that I regularly have to kind of think about because I do breed dumbo. So that's really simple. So in this case, we're going to have, let's put du. Let's put our options here. So we've got 2 of the 4 there, which is 50%. And we've got 2 of the 4 there, which is 50%. So that says if a rat isn't a dumbo in this pairing, it then must be carrying dumbo. So that's very simple, that's very good, very easy. We understand every rat that from that pairing that is not expressing dumbo is carrying dumbo. Right, so what happens if dad is actually a dumbo that, sorry, a top here that doesn't carry dumbo? So he is a du. Now that's very simple. We put the big DUs on there again, and actually all of a sudden you notice we've got 4 out of 4 in that boxes. So we've no longer got 50% or 50%. Because dad doesn't carry dumbo, it's impossible for us to get a dumbo out of that litter. But every single rat is carrying a copy of that recessive little du gene from mum. So we've actually, rather than got 50%, we've now got 100% of dumbo carriers. So they're not dumbos, but they all carry it. And that's quite a simple one. So now we've got a kind of non-carrier of dumbo dad. And then we actually want to change this up, so let's remove from this line. So this time we're going to have mum that is a dumbo carrier, but she's not actually a dumbo herself. So let's say she's one of these from this litter. So what do we get now? So we've got here, we've got another big du from mum and another big du there. Now this is where it kind of like gets tricky. So we've got here, we've got 2 of the 4 big du, so they're not dumbo carriers. Just standard ears, and these are dumbo carriers, but they also have standard ears. Now the problem is, looking at those 2 rats, or 4 rats, or 8 rats, or 20 rats, there is no way of telling the difference between those 2. So what we can say is there's a 50% chance that each of those rats is not carrying. Just realised because I'm a bit useless. So we've got 50% chance of there, and then we've got a 50% chance of carrying, but we won't know. So actually, without what we call test breeding, which is where you take a rat that you don't know whether it is or isn't, and then pair it. So I could take, let's say, a buck from that litter that was du and mate him to Chocobo, who's a dumbo. Of course I couldn't because she's spayed, so it'd be very, very difficult for her to have babies, but I could do that. And then if dumbo babies came out of that litter, I know that he carried. If they didn't, and there was a reasonable number, then I could be reasonably sure he didn't carry. But other than that, you would not know, and that's really important to tell. So now what we're going to do is another kind of connotation, and there's lots of these different connotations, and it's where it becomes a useful tool, because we can try it and then start to interpret it. So this time we've got mum who's a carrier, and we've got dad who's a carrier. So actually let's start right from scratch again. I could change a few, but I'm aware that probably makes it a bit more confusing. So just again, we've got a big du there and a big du there. Right, this one we've got a little du and a big du. Just for kind of neatness sake, we'll do there, but I could actually swap them over if I wanted to do it always in the same order. And then we've got this big du here and a little du there. My handwriting is getting worse, and I do apologise, it is poor. Yes, Wix, that's my ear. And then from here, we've got a little du and a little du. So what we have now is actually a combination that has all 3 in the litter. And we can say, so out of the 4 there, we've got 1 who is a dumbo. So that's 25% of the litter that's dumbo, so 1 in 4, 25%. And actually we've got a dumbo that is not a dumbo carrier, so a top ear that is not a dumbo carrier. We also have 25% because we've only got 1 of those squares. And then we have 2 of these. Now whether I write it that way around or decide to write it that way around doesn't really matter. It's exactly the same because you've just got those 2 different kind of yellow and green ball. They're exactly the same combination, it's just swapped around which side you got it off. So we've got 50% of those. So what we've got in a litter is 25% dumbo and then 75% that look top ear. But actually of those 75%, and this is where people get a little bit confused with the maths, 1/3 won't carry dumbo and 2/3 will. And that's because if we kind of like, we can tell what this dumbo is, we can tell it just, sorry, I've realised I haven't written both on there. We can tell that's a little du, so that's a dumbo rat. All the rest, the other kind of 3, look identical, but of those, 1 in 3 doesn't carry, and the other two do. So you've got a reasonable chance when you're picking that it does, one of the kind of non-dumbos, that it does carry dumbo. But actually, you've also got a fair chance that it doesn't. It's more likely than not that it carries dumbo. So that's one of the things that can come up. And again, of those rats that are not dumbo, the only way you can truly tell is by test mating. Don't believe anybody that tells you that rats that carry dumbo have lower set ears. That's nonsense. Rats have ears. Sometimes they're a bit lower down, sometimes they're a bit higher up. Same true of dumbo ears actually. The ear position has nothing to do with what they carry. So this is basically how Punnet squares work. And then, so we might do that and we might work out for dumbo, but then actually we might have a bit of a think. And what I'm going to do is I'm going to leave that up there. So that's what we'll call dumbo locus. So the next thing I'm going to do is mess things up and say, right, I don't want to think about dumbo anymore. So we've talked about dumbo. We know this litter is going to be 50% top ear carrying dumbo, 25% top ear not carrying dumbo, and 25% dumbo. So that's the dumbo locus, that's all good. Now we're going to look at another locus, and this is where Punnet squares become quite useful. Right, we're going to look at the agouti locus this time, mostly because it's one of the simplest and one of my favourites. Now this, if we remember rightly, agouti is a dominant gene and it is paired with non-agouti, which, if you haven't got anything else on, is black. So we say A is agouti, not carrying self. So what I will say about my use of self here, some people will disagree with it. Again, it's one of those terms that gets used in lots of different ways in the rat fancy. Self can be used either for describing a rat that is not marked, or self can be used for describing a rat that is not agouti. I'm using it in this case to describe a rat that's not agouti. I could equally say not agouti, or I could say black in this case. I tend to use self just out of habit because I judge. We have this whole self class, which is a collection of lots of different colours that are not agouti, and then we have AOV, which has all the agouti based varieties in it in the main. Russian blue has its own class, just to be a bit of an ass. When I say Russian blue, Russian has its own class. It has Russian blue in it, Russian blue agouti, Russian topaz, etc. But that's effectively how I choose to describe it. How you choose to describe it is entirely up to you. So AA, agouti not carrying self. AA, again, inflections there, you can just pick it up. Agouti carrying self. And then little a is self. Or black in the majority of cases. Hey Fufu. Fu is agouti based and she, we think, doesn't carry self, but to be entirely honest, we wouldn't know until we mated her with a self, but she's not had any self offspring to a buck that probably carried self, but again, we don't know. And I'll talk a little bit about that and how you deal with that on the kind of things on this one. Actually, it's quite a good one. So what we're going to start off with is we're going to start off with an agouti mum, and we're going to have her not carrying self, and then dad we're going to have as a self. Mix things up a little bit. So like we did before, AA, so all of them are a big A paired with a little a. So we know from the past, let's put our little agouti locus thing there. I'll put it in a more logical way round this time. And you notice I do this in a different colour because it's entirely separate to what's going on with the dumbo gene. And actually, if I added another colour to it, it would be entirely separate to that. I might do that, I might run out of board space, but it'll kind of give you a feel for how these things all stack up. So we have various different options there. In this case, every single one of them, all four, are AA. So 100% of that litter will be agouti based, I should say. Agouti carrying self. 100%, nice and easy. Again, if I swap that to mum being a rat that carries self, then those stay the same because we've still got that A there, and then we just get AA. So then we've got half a litter that's agouti carrying self and half a litter that is self. So that changes again from 100% to 50 and 50%. So this is how you kind of do it, and then what you have to do is think about, actually, both of those things is true for that particular litter. So how can we add those up together? Now it's very simple in this case because we're looking at a litter that is like two different things. Dumbo doesn't influence kind of agouti or any colour variety. So you can say, I know that I'm going to have here 25% of the litter that are dumbo, and actually of those, half are going to be agouti carrying self, and half of those are going to be agouti, self themselves. And actually, then I've got 3/4 of the litter that are going to be top pair. Some of them will carry self, some of them won't carry self. And actually, just again, half of those are probably going to be agouti carrying self, and half of those are going to be self. So it's kind of like you mix it all up. So dumbo in agouti carrying self, and dumbo in agouti not carrying, sorry, in self. This is where I kind of get confused. I know exactly what it is in reality, but it's one of those trying to keep track of what you've written down. So it's how you choose to describe it. So in this litter, I would describe it as I'm going to get a mixture of agouti and black. All the agoutis will carry self, and actually of those, 3/4 are going to be dumbo, and 3/4 are going to be top-eared, and 1/4 is going to be dumbo. So that's just basically it, adding it all up. If I wanted to then, so the dumbo locus ear position, there's only one option at the moment for ear position, dumbo and not dumbo. Now if we kind of like get rid of dumbo, please don't eat the pen, it won't be good for you, because we know that's a separate thing, and actually now look at a different colour gene. So I'm going to pick one that's quite close to my heart here, and actually also on my shoulder, because it's one I breed commonly. It's also a very simple locus, and what I will try and do over the next, I don't know, while, is I might try and pick out some of the different locuses and talk a bit more in depth about them. I'll definitely talk more about red because it's something that I've read up a lot on, and it's quite an interesting one from my perspective. Right, so this is the red locus. So we call red things either and I should say red is red-eyed dilute or ruby-eyed dilute. So if I grab a little girl here, so what you can't really see very well in this light, her eyes look black. Her eyes aren't actually black, they are very dark ruby. And the same for her sister here. So these both what we call ruby-eyed dilute rats. And that is what's created this nice golden colour. This is topaz. But it all sits on the ruby-eyed dilute locus. And that's why this idea of locuses is really important, because we get topaz on there, and we also get, where is she? Sorry, any trouble? We also get buff on this locus. So these are the two colours, when all the rats start vanishing. These are effectively the two colours that are kind of like the purest colours on the ruby-eyed dilute. So it's either going to be a topaz flavoured rat or a buff flavoured rat. And that is dependent on this agouti thing. So when we look at topaz, topaz is the agouti version, buff is the self version. And I'll kind of show you quickly how that works out. Oops, sorry, try not to kick that. Rats have decided they're leaving me now. They don't like being put. Please don't eat that. No, it's not good for you. The rats also like eating my pens. Right, so ruby-eyed dilute. So it's represented by an R. So big R, that is not red. Big R, little r, not red. And again, it's like this switch idea. Carrying. So this is a rat that is not expressing the ruby-eyed dilute, but it's carrying it. And then little r, it's ruby-eyed dilute. So let's get rid of this stuff here and make ourselves another little kind of table here. Again, it's entirely separate to the agouti. It influences things in different ways. The effects stack effectively, and I'll explain that a little bit more when I do a video on ruby-eyed dilute. But effectively, I don't know. So agouti rat with ruby-eyed dilute gives you topaz, black rat with ruby-eyed dilute gives you buff, which we still have a buff here. My topaz rats ran away from me. They were far too kind of cool to be hanging around. Right, so what we're going to say here is the mum is going to be ruby-eyed dilute, much like Wick here is, Foo is, my two little babies that have run off, Foo's up to no good, are as well. So they are ruby-eyed dilutes, whether they be Wick, who is a kind of, is a buff rat, that doesn't matter. I'm not looking at whether they're going to be buff or they're going to be topaz. I just know that they're expressing the ruby-eyed dilute gene. So mum is expressing ruby-eyed dilute. Dad isn't. So dad is an agouti rat, but a bit like Snufkin here, he carries red. Let's see. In fact, I should say, I don't know that Snufkin does. However, I do know that she does. And the reason I know that Fing does is because Fing's mum was topaz. Whereas Snufkin's mum was agouti, but her mum definitely carried topaz. So it's always a little bit kind of like interesting in that case, those cases. But yes, so mum is topaz, dad is agouti or black, it doesn't actually matter, carrying topaz. The key thing is he's not red-eyed dilute, he carries red-eyed dilute. So exactly the same as we did before. And we can see straight away it's a very similar pattern to what we saw on the kind of agouti locus there. We have two cases of 50% of agouti carrying or not ruby-eyed dilute carrying ruby-eyed dilute, and then we've got two cases here of expressing ruby-eyed dilute. And again, I can mess those around. I can do it kind of big R, which would just then mean that everybody carries ruby-eyed dilute and so on. So if I just go back to the previous one, which was a carrier times a rat that was ruby-eyed dilute, then you combine it with the agouti locus. So I've done that work, I've done the work on both of them. I've looked at the locuses separately, so I've looked at agouti and then I've looked at ruby-eyed, and then this is what it's given me. So the ruby-eyed dilute, red-eyed dilute is, and don't mind if I use those interchangeably, it's one of those things, they mean the same thing. And I should say ruby-eyed dilute is not all rats with red eyes. You can also get Siamese, etc. You can get pink-eyed dilute. It is purely rats that are either topaz or buff or a related variety, like Russian topaz or Russian buff, etc, etc. So then what we need to do, so effectively what's happened is these happen to any of the rats in the litter at the same time. So when we're looking at the ruby-eyed locus, we know we've got a 50% chance of them being ruby-eyed or carrying ruby-eyed. And then in agouti, we know they've got 50% chance of being agouti carrying self or being self. And that basically means we combine them together. So if we want to say that 50% are not ruby-eyed dilute but carrying it, of those 50%, half will be black and half will be agouti, based off this. So half will be agouti carrying self and half will be self. So in that case, when there is nothing else going on, that kind of self will be black. So we know they're going to be, effectively, if you really want to get into the percentages, 25% black, 25% agouti, and then that other 50% is made up of ruby-eyed dilute rats. So that, again, half of those will be agouti based and half of those will be self based. Your agouti base will be topaz and your self base will be buff. I should say, for those of you that are basically outside of the UK, but particularly America, buff is called beige, topaz is called fawn. Bear with me, I'm using the UK varieties here, but that's just in case you're completely confused and wondering what I'm talking about. Those terms tend to only be used in the UK actually. But yes, so then you know that you've got 25% black, 25% agouti, 25% topaz, 25% buff. Nice and even. When you start throwing in slightly different proportions, I've stuck to the very easy 50-50 on these ones, then it gets more or less likely. But the thing is, we've also got loads of other locuses that come into things, and this is where people tend to get confused. So you get Russian locus in there, and then that might be a 50-50 one as well, or actually a 25-75% one, and so on. And each of those effects stack up. And it comes to the point where I've seen people writing down like, oh, there's a 12.5% of this variety, or there's a 6.25% of that variety, getting lower and lower and lower. In reality, that's a real mouthful. and a bastard to stay on top of, particularly if you're not that comfortable with maths. What I tend to do is I'll look at the kind of most common things. So what's most likely to occur in this? So in this litter, it's actually fairly straightforward in that it should be like the black, the agouti, the topaz and the buff are all likely. If I change some of these so that actually we were talking about carrier to carrier, like we were talking about before, and we'd be at 75% and 25%, and actually the same happened in the agouti locus. Then what I might say is actually, if you look at those combinations there, the rats that are not red and the rats that are agouti based are far higher. So I'll say I'm likely to get agouti with a fair chance of black, topaz and a small chance of buff. And that's because when you add it all up, that's kind of roughly what you're getting at. What I might do, and this is one where Punnet squares become a little bit more challenging, I might actually not know what one of the parents are. So I mentioned about Snufkin before, we don't know if she carries red or not. How I would express that is by a dash. So we still know that dominant, so in Snufkin's case, we know that she isn't ruby-eyed dilute because she doesn't have ruby eyes and she's not pale coloured. But we don't know whether she carries or not carries. There's a fair chance she does, but there's also a fair chance that she doesn't. So we know she's big R, and then we don't know what the other is, so we show it with a dash. Some people use a question mark. It kind of doesn't really matter what you want to put on there, as long as it makes sense to you. Unless you're communicating with other breeders, then it's useful to kind of use standard terminology. So that is not red, question mark, carrying. So actually what we do there is put a little dash on Mum's Punnet squares, and then all of a sudden we would have to rework this leg, so it would be R dash, and then it would be R dash. And actually what would be quite interesting about this combination, we don't know what Mum is, but we know what Dad is, so we know Dad carries topaz or buff or ruby-eyed dilute. So actually what we've got up as a possibility here is Dad's kind of ruby-eyed dilute gene and Mum's question mark gene, the one we don't know about. And if we see some topaz or buff or basically ruby-eyed dilute rats in that litter, then all of a sudden we can go back and go, ah, but I had that, which actually means that, and actually means now we know that Mum carries ruby-eyed dilute. And that's what happened with Fu with Dumbo. We didn't know if she carried Dumbo or not, and actually when we mated her up and she got a Dumbos in her litter, suddenly I know that she now carries Dumbo. And that's something that you will find quite a lot in kind of rats. If you've not got a rat from one of those really straightforward litters where one of the parents is a definite example of that variety, that recessive variety, you can't tell what recessive genes they kind of carry. In fact, Chocobo's litter was a funny one. We knew there was a chance that Mum carried mink, and it's like one of these little dashes that had been going along for quite a few generations, and she was paired with Dad, who definitely carried mink, and we're kind of like hoping, and it was, I'll just quickly change it. Sorry, I'm sure talking with a pen lid in my mouth is not ideal. So I should quickly say, mink is big M, little m. So nice and straightforward. I won't write it all out because I think you've probably got the knack of that one right now. So in this case, Mum was not mink and we didn't know, but she could possibly carry mink. And Dad was big M, little m. I've realised that doesn't look that much different. You'll have to believe me, that's a little m and that's a big M. So we knew in all likelihood we'd be getting that kind of layout, so that what we've had before, but with the mink locus, mink gene. So what we're expecting is, if we were really lucky and Mum did carry mink, we're expecting to get this. And just to kind of like, let's make that look a bit bigger. So at best we were hoping for 25% of that litter being mink. Now I should say, mink when you combine it with agouti gives you cinnamon, and mink, when you combine it with self, gives you mink. As it was, mum was agouti, dad was agouti, dad definitely carried mink, mum didn't. So we're expecting, if we're going to get any mink at all, it was most likely to be in the cinnamon format, but only 25% of the litter. That's both 25%, which should have added up all your minks and cinnamons combined, but most of them would have been agouti based. But Chocobo's litter was 3 cinnamons and 1 mink, no other rats. So actually, what we got here for this little M thing was, whilst probability says there should have only been 25% of the litter like that, 100% of the litter was like that. It was only a small litter, to be fair, but that kind of goes to show that all these working it out we've done are fine to a point, but actually only kind of like a kind of educated guess in a way. What really happens is the dice is rolled for every single one of those litter. We put our hands into that kind of pot and pull out 2 balls, and we don't know which balls we're going to get. And sometimes it works out that you get a litter that is entirely different than what you expected. That's not to say we didn't know that there was a chance for cinnamon, but when I described that litter, I would have said it was going to be agouti with a chance of black, cinnamon and mink, and actually what we got was cinnamon and mink. No agouti, no black, and that's kind of a bit of a, so whatever you work out with this, don't believe it's 100% fact. Don't get hung up on the exact percentages. Try and think in big kind of handfuls. Are you going to likely to get those? So in that case, we were likely to get agouti. We had a chance of black and a chance of mink, and I use that kind of language. But it is kind of up to you. You can be really clinical. You can give like a really detailed answer if you want to. You can record it down to the end. But understanding that kind of thing is helpful. So I hope that's made sense. I understand this has been quite a long video. It's one of those, Punnet squares are not for everybody. Don't worry if this just has blown your head. If you're kind of trying to think about how different genes react and how they act together, I find it easier to kind of go into how those genes stack up, and what I'll try and do is cover a few of the locuses to explain that. Things like how the topaz locus works, the kind of ruby-eyed dilute locus, what it does to the colours, and then you can suddenly understand why your agouti rat turns into this golden coloured thing, because you know how it's affecting the kind of pigments in the hair and such, and that's really interesting. And actually, if you're interested in getting ahead on that, have a good read of a website called ratbehaviour.org, and it's one I definitely recommend. Weirdly, though it says rat behaviour, it covers a lot of the sciencey stuff. Some of it's quite outdated. In fact, most of it is quite outdated now. But it's got a really good way of explaining quite a lot of things. So I would recommend having a read of that. That's how I learned a lot of how colours stack on top of each other, and also some of the science behind the colours. Just bear in mind that we know a lot more now than we did back then about these things. Right, I shall leave you and try and round up the furries. I hope you have a lovely day. Over and out from me and Birdco.